Today we're going to look at 5 different examples to find area, or 5 different times area might come up on a test or when you're practicing where you might need the area skill. Number 1 is when you have an array. There are 3 main ways you can find the area when you have an array. We'll start with the most basic. First, if you're not comfortable with any of these ways yet, you can just do this basic way. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can count all the individual squares or rectangles to find that there are 12 square units. The second way is you can skip count by rows. You could say 3, 6, 9, 12. This also works by skip counting the columns, 4, 8, 12. So far we've covered a few ways by just counting. The most important way I want to show you that ends up being the fastest is if you just take the number of columns you see, which is 3 columns, by the number of rows you see, which is 4 rows, and you multiply those two numbers, then you get 12. Just like we were talking about earlier, so 4 times 3 equals 12. And you'd write your final answer as 12 square units. We'll do a few quick practice problems this way. So if I have 5 columns, 1, 2, 3, 4, 5 columns, and I have 5 rows, 1, 2, 3, 4, 5. Instead of having to skip count or count any way, I can say 5 times 5 equals 25. And the final answer would be written 25 square units. Let's try one more like this. There's 1, 2, 3, 4, 5, 6. There's 6 columns by 2 rows. So that would be 6 times 2 equals 12 square units. The second case in which you might find area is when you have an irregular polygon on grid. An irregular polygon might look like this. So just a funky looking shape with all kinds of twists and turns, and you have to find area. This one's pretty simple. You can chunk into manageable rectangles, or you could just count the individual pieces. I know you know how to count, so we're going to skip that way, but I'm going to show you how you could use individual pieces, or breaking them up into smaller chunks. So if I see a rectangle here, a rectangle here, and a rectangle here, rectangle here, I can use those multiplication strategies we just did on the last slides. So I can say this is 2 by 6 in this box, and this is a 3 by 1, or you can just see it's 3, and that's a 2 by 2, which you can see is a 4, and you can see that's 2 right there. So I could take my big chunk of 12, and I'm going to just go ahead and pair these mentally into a 6, so 12 plus 6 is 18, and I could add 3 more, which would be 21. So instead of having to count those individually, I can do some quick math and chunk those and then add them up to be 21. Either way, you're going to get to your correct answer, and then you just finish it off by writing 21 square units. A third case in which you might see area or have to find it would still be on grid, but there are halves involved. It looks like this. So now I can still use my chunking strategy and say here's a 3 by 3 grid, and that would be 9. So 9 right here, and then if you're familiar with halves, which you should be, you can take 2 halves to make one whole. So if there's a half here and a half here, I can put those together to make one more whole square unit. And I can pair these guys off over here to make one more square unit. And then I just have to count up all the holes I found when I did my chunking strategy of 9, and then I can add my leftover ones to find the total. So this would be 9, 10, 11. This would be 11 square units. Let's try one more with halves. I'm going to chunk off my rectangle, and that's a 3 by 4, which would mean 12. And I have 2 more to add here that are holes. That brings me up to 14. And then I have these halves to pair off. Here's 2 halves here, and I like to put a line through them to show I'm done with them to make a hole. Here's 2 halves here to make one more hole, and then there's a half left over. Alright, so this one's going to have a mixed number answer. We have 12, 13, 14, 15, 16, 16 holes with a half left over. So this answer would be 16 and a half square units. The fourth way you might see area, or have to find it, is interesting, where you have to estimate it with partial squares. Looks like this. So I'm going to go ahead and chunk just to get that part done. I'm going to change up my color a little bit. Alright, I have this right here, would be a 2 by 5, and we know 2 times 5 is going to make 10. And then I have this stuff. Alright, this is what we're going to focus on for this problem. If you can visualize kind of taking these tiny little guys right here and filling them in those spaces, and those are gone now, and those are just white boxes, then I'll just have 2 whole square units left over. So that 10 and that 2 would make 12 square units. And that's kind of what you have to do with these. It's almost like rounding, you know, when you estimate with these, because you're kind of just ignoring anything that's less than a half, or just kind of pairing it up with other stuff that you need to fill in, like over there. But you're not counting anything less than a half as an extra whole. Alright, so just kind of use your common sense and your number sense and what you know about shapes to figure these ones out. Alright, let's look at one more like that. So I'm going to chunk off here. That's a 3 by 4. 3 times 4 is 12. Here's a 2 by 2 sitting as holes up there. So we're up to 16 square units. And there's one more square unit that's a hole there. So now we're up to 17 square units. But then we have these. Alright, and I actually set this up here so we can do more than visualize and actually see how that might look. So if we move this, and we kind of fill it in just roughly, you know, that definitely looks a whole lot more like a hole than it does nothing at all. So this is gone, so we're not counting that as anything, but if we put those two together, that makes about another hole. So we're going to go ahead and add that on as a whole while we're with this estimating problem. So 17 plus that one extra one that we made here would be 18 square units. Alright, the fifth example I want to show you is when you just have a rectangle or a square and you're not on a grid, but they give you numbers as units in the customary or metric system. Like this one is centimeters, which is in the metric system, and we're just going to find the area that way. To do this, it's much similar to the arrays we started with. You just take R12 and R2 and you multiply them. So that would be 12 times 2 is 24 centimeters. Alright? Or when we're finding area, we could say 24 square centimeters. For the last one, we have a square. We're only given one side, which doesn't really matter because if we know our definition of a square, it means all sides are congruent, which means they're the same size and the same shape, which means this side would be the same as this side. Alright, and these sides would also be 4. So we just take 2 of those sides and we multiply them. Alright, because with area, the length times the width would be your answer. So 4 times 4 would be 16 square centimeters. Alright, I hope this video helps.